Good day, friends. How are you doing? Right now, let's try to solve this problem, which is about torque. And I hope that by the end of the video, you will understand how to work with torque and how to calculate, how to solve problems about this topic. Okay, so our problem is a smooth, tall cylindrical glass with an internal radius of 6 centimeters contains a stick of length 13 centimeters and mass 250 grams. With what force does the upper end of the stick act on the wall of the glass? So if we look at this image, which I have drawn before recording this video, is exactly about our problem. So we have this kind of a glass. It doesn't matter what is outside because everything that we are going to work with is inside of the cup of the glass. And the main object that we are going to work with is the stick that stands in this kind of pose. Okay, so what we are asked to find is the force that is acting on the upper wall of this glass, which is this normal force. Let's call it normal force 1, okay? Also, we have other forces which are acting on our stick by this glass, which are this normal force, let's call it normal force 2, which is opposing normal force 1, right? And definitely we can say that those two are equal because this stick is not moving in horizontal and it is not being rotated. That's why we definitely know that normal force 1 equals to normal force 2. Also, we have this vertical normal force 3, which doesn't let our stick to fall downside. And also there is a force, it is weight definitely, which comes from the center of mass. Okay, so I believe this is, these are all the forces which are acting on our stick in this case. And let's talk about torque. So we have something called torque. So this is the thing which I call is rotational force. This is force cross product R. So it's exactly the same thing, which is a force, but for rotational case. So this is the force which is trying to not move our object, but rotate our object, right? And the most important thing about this is this particular thing, which is this symbol. It is not x, it is not multiplication, it is cross product. This thing, okay, let me choose some different. Yeah, this thing, it is called cross product. What this thing means in general is something like this. Let's choose some pivot, yeah, and let's draw some stick, something like this. And we have some force which is acting on our object. For example, like this. Let's draw one more force which is acting like this. So let's call it force 2, let's call it force 1. This cross product means that our force and the radius of our object, right, this entire length, they have to be perpendicular to each other. So if we have some case like this about force 2, this thing cannot rotate our object, but this thing exactly can. What about some different situations? Something like this. Let's say something like this. And it is about, let's say, 30 degrees. Can this thing rotate our object? Of course it can. However, not the entire force which is acting on our object at a 30 degrees, but only its horizontal, vertical component, not horizontal. This component of the force, let's call it some F3. This has to be F sine alpha, F3 sine alpha. This is F3 cosine alpha. So this is really important. Why? Because this component of the force 3 cannot rotate our object. It can only pull, however, it cannot rotate. What we need is rotation, it is torque. Only F sine alpha can rotate our object. So what is important to understand that our force and radius that we have is those two have to be perpendicular to each other. What about this thing? What is a pivot? Pivot is a point around which we are trying to move around our object, right? So our pivot might be somewhere else like this. Then our radius will not be this entire part. Instead, our radius will be only this small part. This part will be our radius because we are working always with a pivot. This pivot point is always important because our radius is always noted from the pivot to the point where we are trying to move around our object, right? Okay, so let's take all these things out and let's look at this. What we definitely see is that this normal force is trying to rotate our object like this side. Let's call it torque 1. This normal force 2 tries to rotate it like this. Let's call it torque 2. Normal force 3, instead, it is trying to rotate our object this side, which is torque 3. And mg, as you can see it is trying to rotate our object this side. So it is torque 4. Okay, let's work with this. However, first let me copy all these things in order to show you something very important. Let's take this image. Let's rotate it a bit, something like this. Okay, this is pretty good. And yeah, let me take this out. If you look at this, these forces are not perpendicular to our stick. That's why we need to take only its components, only vertical components which are acting on our stick, right? So let's take some angle alpha. Let's call it this point alpha. And let's call this thing, yeah, here it has to be alpha, like this. We definitely know this by law of Z, that if something like this we have, then this angle also has to be alpha. This angle is alpha, which means that this angle is alpha. Okay, what do we have in here? The thing is, right now I can take this thing off, and let's try to work with these forces. Well, definitely what I can say about these forces is something like this. Let me choose, I don't know, like green. I can say that this normal force is pulling my stick downwards and to the right, right? So it looks like this. This normal force 3 tries to pull it upwards and to the right as well. This normal force 1 is trying to pull upward and to the left. And mg is trying to pull it somewhere here and here. Okay, good. However, which angle is which? Definitely. If we look at this, this angle has to be 90 minus alpha, right? 90 minus alpha, because this entire part is 90 degrees, right? So if we go back to our image, it looks like this. If you didn't understand what is going on, it looks like this in our situation, in our true image. Normal force looks like this, here and here. mg looks here and here. And normal force 1 looks here and here. Okay, good. So it's exactly what is going on in our image. Okay, which angle is which? Which is normal force sine alpha, which is cosine alpha? So we have here 90 minus alpha, right? So it definitely has to be, if we're looking at this, this thing is sine alpha, sine 90 minus alpha, right? So because it is opposite, right? I can call this thing normal force 2 sine, but this thing is 90 minus alpha, which is important, which is normal force 2 cosine alpha, cosine alpha. So we know this law that sine 90 minus alpha gives us cosine alpha. That's why we can say that this part is normal force 2 sine alpha. This is or sine alpha. Let me take this out so you don't mess this up. Okay, so it looks like this. Good. What about this angle? Well, if we look at this, this angle has to be also 90 minus alpha, but this angle, it has to be, this angle has to be alpha, right? Because this is 90 degrees, this thing is 90 degrees, and this thing is 90 degrees. So if this thing is 90 degrees in here, definitely if this is alpha, this is 90 minus alpha. If this is 90 degrees, if this is 90 minus alpha, this is alpha, okay? So let me take all this out so you don't mess this up again. So it is much easier. In this situation, this has to be normal force 3 cosine alpha because it is adjacent. This is normal force 3 sine alpha because it is opposite. Okay, let's look at this situation. We have here, again, so if this angle is alpha, it means that this angle is 90 minus alpha, right? So let me take it, put it here. Okay, this is 90 minus alpha. And this opposite side, this thing, has to be n1 sine minus 90 minus alpha. Why? Because it is opposite, it has to be sine, but our angle is not alpha, it is 90 minus alpha. That's why we put it here, 90 minus alpha, okay? Okay, good. So I take this out, and if this is n1 sine 90 minus alpha, it definitely means what? It means that it is n1 cosine alpha. Again, sine 90 minus alpha gives us n1 cosine alpha. Okay, so let me put it like this here, and this thing has to be n1 sine alpha. Sine alpha. Okay, good. I like it. I like it. What about mg? Yeah. So if we work with mg, it must look like this. Well, if this is a triangle like this, look at this. This is 90 degrees. This has to be 90 minus alpha, and this angle has to be alpha, as you can see it, right? So let me take all these things and put it here. This has to be alpha, and as you can see it, it is adjacent. It is connected with alpha. That's why this angle has to be mg cosine alpha. This thing has to be mg sine alpha. Okay, good. Right now we can definitely see what is going on in our situation, and as we have drawn it here, it has to be something like this. This is our torque 1, which is trying to pull it here. Normal force 3, it is torque 3. This is torque 2, and it is torque 4 by mg, right? So if you misunderstood all this part, so I ask you to watch all of this again. It is the same situation, in fact. But the thing is, I've just rotated this thing to be horizontal and a little bit more comfortable, right? Okay. Right now, we definitely can say that our stick is not being rotated, which means that the sum of torques, okay, let me write it here, the sum of torques equals to 0, because nothing is being rotated, right? Our stick is not being rotated. That's why the sum of torques is equal to 0, okay? So we can choose any point as a pivot, because this thing is not being rotated, and I have a very good idea to solve this problem. Let's choose, for example, this point as a pivot. Okay, I've pointed it with this pink color. This has to be our pivot. And if you ask me, in this image, it has to be this point. Okay, so if you ask me, why did I choose this point to be my pivot, then I will tell you something like this. So look at this. We have what? We have torque 1, which is, okay, let's say that clockwise, clockwise things, torques are positive and counterclockwise are minus. Okay, so what do we have clockwise? We have torque 3, which is trying to rotate like this. We have torque 4, which is also trying to rotate like this. They both are clockwise, which means that this is torque 3 and torque 4. They are both clockwise. What about counterclockwise? Well, these are torque 2, which is trying to rotate like this, and torque 1, which is also trying to rotate like this, counterclockwise. Then I will write it something like torque 1 and torque 2. Okay, good. So what it means? It means that sum of torques, which is torque 3 plus torque 4 and minus torque 1. Why? Because it is negative, it is counterclockwise, and torque 2 as well, minus torque 2. They are equal to 0 because our object is not being rotated. Okay, good. What can we do with this thing? Well, let's move this torque 1 in here and torque 2 in here, so everything becomes positive. So it has to be something like this: torque 3 plus torque 4 equals torque 1 plus torque 2. Good. So what do we have? We have this formula, force cross product radius. So our pivot is this point, which means that the pivot, the radius from the pivot to the force is 0 for N3 and N2. That's why I have chosen this particular point, because it is more comfortable to us to work with, right? So I can say that from the pivot, the normal force 3 and normal force 2 are 0 radius away. That's why it is comfortable to me to work with this particular point. We can choose any other point, but this is more convenient to me to work with this point, okay? So torque 3 is normal force 3 cosine alpha, because this thing, let me show it, I don't know, with this red, this thing cannot rotate. This thing cannot rotate. This thing also cannot rotate. This thing also cannot rotate. What can rotate is, let me choose some blue, this one, okay, no, not blue, it is this yellow, yeah, this thing can rotate, this thing can rotate, this one, and this one. So what you see as red, yeah, those forces cannot rotate our stick. Only the yellow lines, green lines, which are being highlighted with yellow, only those forces can rotate our object because those are perpendicular to our stick, right? Okay, so normal force, torque 3, the force of the torque 3 is N3 cosine alpha. That's why let me write it here. This is force, N3 cosine alpha, and the radius is 0. Okay, so what about torque 4? Let's plus torque 4 is our mg. It is mg cosine alpha. Okay, it is mg cosine alpha. However, the distance from the pivot is not 0 because it has some distance, this distance. But as you can see it is definitely the half of the entire length, right? So this has to be just L divided by 2. This distance will be multiplied L divided by 2 equals what? Torque 1, which is N1 sine alpha. This is N1 sine alpha multiplied L, the entire L. Why? Because from the pivot, my force, normal 1 sine alpha, is the entire length of the stick. That's why it has to be just L. What about torque 2? This is N2 sine alpha plus N2 sine alpha. But it is 0. Why? Because it is 0 distance from our pivot. Okay, so that's why I can just annihilate this part and annihilate this part. We have only this thing. Okay, so what we have here, let me just bring it somewhere here. Okay, we have this thing, which is pretty good, in fact. Why? Because let me choose this, let me highlight this part. Look at this, cosine alpha L divided by 2, and sine alpha L, sine alpha multiplied by L. why these two things are important? Well, we definitely know m, yeah, it is given. We know gravitational acceleration, it is just 9.8 and it is about 10. We need to find n1, this is definitely that thing that we are trying to find. However, what about these things? Why did I highlight them? So look at this. L divided by 2 multiplied cosine alpha, excuse me. This thing is what? So if I'm talking about L divided by 2, it is this part, right? It is the half of the length. And if this is my alpha, right? So cosine alpha below that L divided by 2 is this thing. But this thing is also what? This is radius, which is given. That's why I can just say that this thing is radius. It is convenient to me because I know the radius, it is 6 centimeters. What about this thing, sine alpha multiplied L? Okay, so if this thing is still our alpha, this thing, what about our L sine alpha? Well, definitely it is this entire part. This entire part. Well, because the L is this entire stick's length, right? And opposite to this entire L is this thing. Let's call it some H. And this is not that hard thing. Why? Because we know this entire L, which is here. And we know what is this thing. It is just 2r, 2 radiuses, which is just 2 multiplied 6. And this thing becomes 12 centimeters. And guess what? This is just a Pythagorean theorem. This is just a triangle. Yeah? So, yeah, look at this thing. This triangle. This triangle. It is just a Pythagorean theorem. We have 13 centimeters and 12 centimeters. That's why there has to be something in here. So, yeah, let me take this triangle somewhere here. Yeah, it looks something like this. Yeah, it doesn't matter. So basically it's something 13 centimeters here, 12 centimeters here. There is some H. We'll definitely know that if this is A, this is B, this is C. We know this Pythagorean theorem, which is A squared plus B squared equals C squared. And this is A squared is just 12 squared plus our H squared equals 13 squared. This is 144 plus H squared equals 169. H equals square root, because we need to get rid of this square, is just 169 minus 144. And H equals just square root 25, which is just 5. This is pretty convenient. I can call this sine alpha L just an H. Right? So we have what? We have here mgr equals n1 multiplied h. And if we need to find this n1, is n1 equals mgr divided by h. So if we put the numbers, then it would be just 0.25. Why? Because we have here 250 grams, which is just 0.25 kilograms, right? Then we have here g, which is just, let's say it's 10, radius, which is just 0.06 centimeters, right? The radius is centimeters. That's why in meters it has to be just 0.06, and height has to be just 0.05 because it is also in centimeters. Okay, so what can we do is just, well, this thing goes, this thing goes. Well, this is just 5, and we have what? We have here 50 multiplied 0.06, and I can definitely say that this thing is just what? It is 5 multiplied 0.6, it is 3 newtons. This is the answer of our normal force 1, which we were meant to find, and we have found it. This thing is our answer. The force which is pressing on our wall from the upper side due to our stick is 3 newtons. It is right here. Okay, so thanks for your attention. I hope that you understood this topic pretty well. I hope that you remember this thing, that force and radius from the pivot has to be, those two have to be cross product, which means those two have to be perpendicular. And you need to choose only its perpendicular component, and you don't need another component because the second component cannot rotate. And torque is just a rotational force. Okay, I hope that everything is clear to you, and if not, you can definitely write me privately. Okay, this is the end of the video. Thanks, goodbye.